Anyone? Let's say 2x squared minus 8 over x plus 2 times x minus 1. Okay. What is the degree of the top? What is the degree of the bottom? Very good. So is it type 1? Very good. Type 1. Good. So let's start with the table. I will look at the function and perform some operations before I decide anything. So what will be the first thing that I should work on? Say it again. I will never distribute the denominator on any denominators. We'll never distribute the factors. We always want them factored. We pray for them to be factored. We never ever, I'm kidding, of course. We never ever distribute the factors and denominators. We work hard to factor them, right? We don't want them distributed because we're getting into trouble. Now, if you say, let's distribute just to find out the leading coefficient, then I will have to say yes. Then for that reason, I will. But since it's x times x and that's x squared, I know exactly the leading coefficient. But other than that, I will never distribute the factors in the denominator. So then the function is, what do we need to do to it? Look at the function. You don't have to do anything. You don't have to remember anything about graphing this. But if you look at the function, you'll say, yes, you need to do ba, 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 ba. Just common sense for now. Yes, but I have to factor 2. I have to factor the numerator. I have to see what's happening, and then I have to find the domain. Yes. So first, obviously, 2 is a common factor, x squared minus 4 divided by x plus 2, x minus 1. Always try to be ready to prep the function as much as possible. Good. So then again, I have 2, and what else I will have to do to the top? That is crucial because that's why we did every preparation from before this chapter. So what do you recommend for the top? Very good. X plus 2, x minus 2. Now I will state the restrictions. How many restrictions? Yes. And they are? Awesome. Very good. So only now I can do what? Only one. Now I can, again, look at the function. After I stated the restrictions, what should I do next? Look at the function. Very important to look at the function carefully. Any suggestions? I know you see this. I mean, it's not. Is that clear? Only after I state restrictions, I am allowed to simplify. We've always done that with rational equations, right? We always stated the restrictions, and then we did whatever. Good. So then the function becomes this. Is this okay, everyone? Perfect. So now I have the domain. You already gave me the domain. By saying x cannot be -2 and x cannot be 1, you already gave me the domain. So then negative infinity, infinity, -2, 0, 1. You told me that x cannot be -2 and x cannot be 1. And what did we say last time about a factor that disappears and a factor that stays? X minus 1 stays. Obviously, there is nothing I can do to it. It cannot go away. But x plus 2 is a factor that went away. A factor from the top with a factor from the bottom. What does that say about the function? Yes, very good, awesome. So this is a whole. The factor that stays will be awesome. x equals 1 is a VA. Perfect. That's all I needed. Since this is type 1, what will be the horizontal asymptote? The leading coefficient for the top is 2. The leading coefficient for the bottom is 1. So then y equals 2 over 1, in other words 2, is the horizontal asymptote and also the end behavior of this function. So y equals 2, horizontal asymptote. Now I have to continue with filling out the chart right here, left and right of the asymptote and the whole. So this is the function that we're working on because we simplify this into this, stating the correct restrictions. So now I have to plug in -2 in this function. -2 minus 2 is, so let's write it. F of -2. It's 2, -2 minus 2 divided by -2 minus 1. Because I have to put this number here. I know it's a whole, but I want to know where the whole is. So -2 minus 2 is -4. -4 times 2 is -8. -2 minus 1 is -3. So the answer is 8/3. So 8/3 on this side and 8/3 on this side. Left and right of the whole. Once you say that this is a vertical asymptote, what will I write left and right? Definitely. What has to happen left and right? If a rational function has a vertical asymptote, this is the vertical asymptote. What has to happen left and right of the vertical asymptote? What will the function do left and right? I mean right and left for you. Yes, but I don't know if it's this, or this, or this, or this. So I can write infinities right away, but I don't know their sign yet. How do I know these? Because we concluded that this is a vertical asymptote. I'm going to use two numbers, like 0.9. As you see, they're up there. I'm not putting them in the table. I'm not going to plot those numbers. I'm only going to use them to find the sign of the infinities. So here it is, with 0.9. 0.9 here and 0.9 here. What is the sign of the top with 0.9? Negative. What is the sign of the bottom with 0.9? So what is negative over negative? So what will be the sign of this infinity when I plug in 0.9? That's it. Now I want to plug in 1.1. 1.1 minus 2, sign. Perfect. 1.1 minus 1. So now negative over positive will give us the sign of this. Negative. I only need the x and y intercepts. So I will plug in 0 in order to get this number. 0, 0. -4 over -1. 0, 0. 2 times -2 is -4 over -1. What do I get when x is 4? And last one, how do I find the x-intercept for a function like this? X-intercept when? Very good. Y equals 0, or 2 times x minus 2 over x minus 1 is 0. When is a fraction 0? Or, don't say anything, just think in these terms of a proportion. Same thing. Both work. You either say a fraction is 0, only top is 0, or just cross multiply, and you will get the same answer. So 2 times x minus 2 equals? Perfect. So therefore, x must be 2. So we go up here, 2, comma 0. Careful where you put 2. It has to be between 1 and infinity, of course. Can this function be symmetric with a vertical asymptote at 1 and a whole at -2? No. So all I have to do is just mention function not symmetric, and I'm fine with that. F of x is not symmetric. Perfect. Let's make sense of the information we have, plot the points we have, and then decide what the graph is doing. So let's see. When we graph a function with asymptotes, what do we have to graph first? Of course. Awesome. Thank you. X equals 1 and y equals 2. They're not part of the graph, but they have to be graphed first. So now I'm trying to make sense of this table. I don't care for anything else anymore. That's it. So from approaching the horizontal asymptote, the function will go through a hole, will cross the y-axis at 0, 4, and it will go towards infinity on the left-hand side of the asymptote. From positive infinity, we'll go through a hole, cross the y-axis, and approach infinity on the left-hand side of the asymptote, of the vertical asymptote. On the other side of the vertical asymptote, it's coming from negative infinity. It crosses the x-axis at 2, 0, and approaches y equals 2. That's what I see. One more time. From negative infinity, going through a hole at negative 2, crossing the y-axis at 0, 4, and going to positive infinity. On the other side of the asymptote, coming from negative infinity, crossing the x-axis at 2, 0, and approaching 2 from under the horizontal asymptote. That's what I see. Does it make any sense, what I'm showing? Yes? Okay. So now I'm going to just use the information I have summarized in the graph, in the table, sorry. So then at 0, 4, I have a point. At 2, 0, I have another point, 2, 0. At negative 2, 8 divided by 3 is almost 3, but definitely more than 2, right? So I'm going to say 8 divided by 3 is somewhere here. So from coming from 2, above the horizontal asymptote, crossing at 0, 4, going towards infinity. Coming from the negative side, from negative infinity on the right-hand side of x equals 1, crossing at 2, 0, and approaching y equals 2 from below the y-axis. I don't want these graphs to use more than 4 minutes of your time. Okay? Now we can use the graphing calculator and graph the function. How many functions do I have to put in the graphing calculator? Because the graphing calculator doesn't know as much as you do about this function. 2 functions. Every time you put a rational function in the calculator, please don't forget to put parentheses around the top and parentheses around the bottom. No matter what you have. So in parentheses, the top was 2x squared minus 8. Close the parenthesis and divide by, in parentheses, the whole thing, x, again parentheses, x plus 2, close, open, x minus 1. And don't forget to the second parenthesis. And what would be the second function that we have to put in case we want to graph the calculator and check?
1.
Careful?
2.
2. Very good. Okay, now I'm going to choose the viewing window because I already graphed the function, and I may not want to window. I may not go to more than negative 5, 5, with a scale of 1, and negative 2, 8, with a scale of 1. Just because. Okay, here's coming from approaching 2. crossing at 0, 4, going to infinity. From negative infinity, crossing at 2, 0, approaching 2. And this is the second function, which is the horizontal asymptote. Can anyone give us the range of this function? Yes. Awesome, thank you. Exactly. Oops. No one can. Union. Careful, we have a hole. So 2 comma 8/3 union a/3 infinite. Only because there is a hole in there. Oh, and by the way, the graphing calculator, we know that there is a hole right here. We can see it, but we can also plug in the function with second and table. What is my table right here? Second and table, if I plug in 8/3, what should I get? A divided by 3. What should I get? Oh, no, it's frozen. Oh, I know it's why it's frozen, because it goes to default all the time. Yes, that's what. I keep forgetting that. Okay. So when we plug in, actually -2, we get error. Good. So we can go back to the viewing window. If we want to see that -2 comma 8/3, I will have to zoom in here. So between for x between -3 and 0, with a scale of 1, it's okay, and y minimum 0 to 4. That's all I want to see. I want to see this little hole right here at -2. And this is -2 comma 8/3. As we knew. Everything okay? Perfect. Do we need another example? Type 2 is everything identical. It's just that the only change is the horizontal asymptote will be 0. Can we look at the last one, type 3? Is this okay? Any questions about this? Any questions? Okay, so let's look at type 3. Type 3 is, for example, f of x. Oops. Let's choose. They are on page 427. Let's start with 85. Oops, that's not a good color. 85 on 427. Okay, so here it is. X squared plus x minus 6 divided by x minus 3. Now the question is this type 3? One more time. Type 1 requires same degree over same degree. Type 2 requires a higher degree in the denominator. It's not type 1. It's not type 2. Is it type 3? Only if the degree at the top is exactly by 1 unit higher than the degree of the bottom, so that when we divide, we get a line. Yes?
So can you not do all with the higher degree?
No, not in this class.
Okay.
We don't have enough information. We will use the calculator from the beginning till the end. Other than finding the domain and x and y intercepts, we can't find anything else.
Okay.
And vertical asymptotes, we cannot find anything else about those other functions. I think they are way beyond the scope of the course. I don't even think that they present anything here like that. Even with calculus, we have some difficulty with them. Okay, so it is type 3 indeed. I will get it ready and prep it if I can in any way, shape, or form for what's next. So what do you think we're going to do immediately? What can be done? What can I think of doing here? Only what did we do here as the first step? that will definitely apply here, or at least we hope. Exactly. Very good. I'm getting it ready for filling out the table and finding the rest of the information. So then how do I factor the numerator? Very good. Awesome. So now let's get a table going. You understand why this is so important to factor from the beginning, because if there is a factor that I can get rid of, that becomes a hole. If there is no factor that I can get rid of, there is no hole in the graph. So that's the first step. Okay, now I'm also ready for the domain. So what is the domain of this function? Very good. Indeed. Anything but 3. Because 3 may make the denominator 0 and the function undefined. Awesome. Thank you. Okay. Now, I would like to determine what happens when x is 0, so I can put this value in here. So what happens at x equals 3, first of all, before we even plug in 0? Is there a hole? If I can simplify it with an x minus 3 from the top, then it's a hole. If it stays forever, then it's a vertical asymptote. So yes, there is no x minus 3 at the top. I cannot get rid of it. It must be a vertical asymptote. So x equals 3 is a VA. I know that left and right, the function will go to positive infinity or negative infinity, whatever sequence, I don't care, because I'm going to use a 2.9 and a 3.1, something very close, left and right of 3. When I plug in 2.9 in x plus 3, what sign do I get? Perfect. When I plug 2.9 in x minus 2, what sign do I get? Perfect. When I plug 2.9 in the denominator, what sign do I get? Very good. So then what is the sign on the left-hand side of x equals 3? Perfect. Awesome. Thank you. Now with 3.1. When I plug 3.1 in x plus 3, what do I get? Positive. When I plug in 3.1 in x minus 2. And when I plug in 3.1 in x minus 3, positive. What will be the sign on the right-hand side of the asymptote for sure? That's it. So we know the domain. We know that x equals 3 is a vertical asymptote. We already know the behavior of the function left and right by plugging those numbers close to 3. Now let's plug in 0. Negative 6 over negative 3. Good. Let's also find the x-intercepts. When is this function 0? When x plus 3, x minus 2 over x minus 3 equals 0, or 0 over 1. So what are the options? When will this function cross the x-axis? When will y be 0? We cross multiply. Very good, awesome. Very good. We go back to the chart. I put negative 3, 0. And 2, carefully, is right here. 2 comma 0. 2 is between 0 and 3. So when x plus 3 is 0, I get x equals negative 3. When x minus 2 is 0, I get x equals 2. I put 2 comma 0 between 0 and 3, and I put negative 3 to the left-hand side of 0. It's almost done. One more step. Since the numerator has degree 2 and the denominator has degree 1, this function will not have a horizontal asymptote. Okay. So type 3 have slant asymptotes. Rarely more than 1, but it can happen. So How do I find the slant asymptote? Remember, it was x squared plus x minus 6 divided by x minus 3. Which division would you like to use? Synthetic, or that's why I refreshed your memory in 3.3 for this. For this type 3, only for this one. So would you like to use synthetic division or long division? By the way, is synthetic division applicable here? It is, because the denominator has degree 1. It's x plus or minus a number. So we can use long division or synthetic division. Why would I need that? So the answer will be a quotient plus a remainder over the divisor. This, which is the quotient, will be the slant asymptote. Only the quotient. Because this portion will go to 0 at infinity. That's the reason why we need to perform the division and find the quotient. So, which one? Long division or synthetic division? You choose. Long division? Very good. Both are in descending order. Is there a missing term from the top? Very good. So then I have x squared plus x minus 6 divided by x minus 3. Well done. So then the top, x times what? What is the first question? X times what is x squared? And remember, at the top, we do not lie. You know what I mean? I'm just trying to be funny, just to refresh your memory that when we write underneath, we change the sign. But not for the top. X indeed. Now we distribute to both terms. X times x. I have to subtract. X times negative 3x. X times negative 3. Negative 3x. Change. Very good. Perform the operations I see. Next step. X times what is 4x? A sign. We never lie at the top. So x times what is 4x? It must be positive 4. So now 4 times x is 4x. I subtract. 4 times negative 3 is negative 12. But I subtract. Negative 12, and that's how I get positive 12. What gets in the box? 6 indeed. So can anyone dictate the final answer from here? Quotient. So what is the quotient of this division? X plus 4, very good, plus the remainder. Perfect. This is all we care about. Y equals x plus 4 is the slant asymptote. Okay, so finally I come back to my table. Can you tell me how will we graph this? It's a linear function with a positive or negative slope. Positive. Will I graph it like this? Because I need to graph it, right? Like we graph the horizontal asymptote, I have to graph this slant. Will I graph it like this, from negative infinity to positive infinity, or like this, from positive infinity to negative infinity? Yes, because that's how this positive slope, the function will do the same. It will have to follow the asymptote. Like it follows the horizontal ones, it will follow this one. So what is the end behavior of our function? Same. Yes. So then I go back to the table. I put negative infinity and positive infinity and write my note. Y equals x plus 4, slant asymptote. Now the table has everything, except the symmetry. A function with a vertical asymptote at 3 cannot be symmetric with respect to anything. not with respect to the origin, respect to the y-axis, and not with respect to the origin. So I will mention function not symmetric. That's all I need. Okay. So let's see what the chart is, the table is telling us. So I think I wrote the yes. Let's graph what first, and then discuss it, and then check it. The asymptotes. There are two asymptotes. One is at x equals 3. And the other one is this. I have to find 2 points for it. When x is 0, how much is y?
4.
Very good. 1, 2, 3, 4. When y is 0, what should x be for y to be 0? So here's the other asymptote. Y equals x plus 4. Okay, now let's do this together as we did before. Try to understand what's happening here, and then graph it. Ready? So from negative infinity, the function crosses at negative 3, 0, crosses at 0, 2, crosses at 2, 0, and comes back to negative infinity. So from negative infinity, crosses at negative 3, 0, crosses at 0, 2. I don't know if it turns here. It may turn before. That part we don't know. We can't determine that in algebra. And then comes down to negative infinity. Now here, this is very weird. What does that mean? A function cannot connect infinities like this. It connects infinities like this. Cannot connect infinity, right? This is a function that connects infinities, x squared, right? So there must be something like this up there. So for now, I'm going to say that it turns here. I doubt. But you don't ever have to adjust the graph other than just say, okay, I realize that it really turns here. Or, okay, I realize that it really turns here. I'm fine. That tells me that you understand what the graph is all about. We can determine this minimum with the graphing calculator, and we will be able to determine this maximum either before it hits the y-axis or after or here. If it's here, it's clear. It's 2. That's all we can determine. I will not put a problem like this as a mandatory problem. I will make it extra credit to choose from. If you understand it, if you're comfortable with it, it will be something to choose from. But I don't think that this is a major topic in this class. Type 3. The other two, yes, but type 3. Okay, so the second function will definitely be, of course. It will not be a difficult problem. You will not have, but I just think that it's quite long. So x squared plus x minus x, close the parenthesis, and divided by, don't forget parentheses. You will get something that you don't want without parentheses. Okay, so I know the graph. I know that it's up there happening something, so I have to adjust the viewing window definitely. So I'm going to go to window. From my graph, a negative 5 to 5 will be enough for the x-axis. Negative 5 to 5 with a scale of 1. Y minimum, I don't really care for that much. Okay, let's say negative 4. But definitely for y maximum, if I want to determine that minimum, it should be up there. I don't know how high. I may have to adjust it. I'm going to say 50 for now with a scale of 5 or 10. I don't know. I would like to see and be able to determine that maximum. As you see, it's coming from, oh, so it's not that bad. So I just have to see it more on that side. So it crosses at negative 3. It crosses at 0, 2. It crosses at 2, 0, going to negative infinity. It's coming from positive infinity and approaches or follows the slant asymptote towards infinity. So let me change that. So I will go to 10 or maybe even 15 with a scale of 2. And maybe I don't need that high. Maybe 40 or 30 would be enough with a scale of 5. Okay, let's try now. Okay, it looks much better. Good. I can determine the minimum and I can determine the maximum. So as I expected, I don't think the maximum is here, but it's possible. We can check. And a minimum is somewhere here. This is 0.2. So between 2.1 and 4. 1, 2, 3. What did I have here? I had the scale of 2. Okay. So 2, 4, 4, between 4 and 6. So I go to second and calc. I want to determine the minimum between 2 and 6. Between 4 and 6. Sorry, oops. I want the minimum 3 between 4 and 6. I did something again. What did I do this time? I want the minimum 2, 4. Okay. No, the right bound is not 6. I can move it. Let me move it. Okay, enter. And yeah, I did something. It didn't do what I wanted to do. Okay. Yeah, that's good. Well, that's fine. And then the right bound. Okay. So that's the minimum at 5.4, 11.9. So 5.4, 11.9. I will put it in the table. And now for the maximum, I see the maximum is somewhere between -1 and -2 and 2. So second and half. This time I want the maximum, which is 4, between -2 and 2. I don't want to guess. Did I choose something else? I want a maximum. The right bound. It doesn't like something that I'm doing. Okay, 4. Okay, is that better? Left bound, I want -2. Right bound, I want 2. Yes, give me the maximum. Let's see where it is. Ah, it's on the right hand side at 0.55, 2.1. So 0.55, 2.1. So it was on the right hand side of the vertical axis of the y-axis, not on it and not on the left. So we did not know. We had to determine this with a calculator. So we determined that this minimum is 5.4, 11.9, and we determined that this maximum is actually here, and it's 0.55, 2.1. So the actual graph should have been slightly elevated here. If you do that, you don't have to change anything. Yes, Brian, you don't have to adjust anything. I'm fine.
Okay, so if we just set the maximum, then we don't have to adjust it.
No, nothing. Like I did. So before I looked at the graphing calculator, I showed 3 different options, and now I go back and I adjust it without erasing anything else. Your understanding of the graph for me is more valuable than copying it from the graphing calculator. Everyone can do that. And this is the end of rational functions, but I would like to show at least one word problem to see why these functions are so important. Why do we even study them? So let's look at problem 101. It says we are given a function. It models the pH level, f of x, of the human mouth, x minutes after a person eats food containing sugar. So every time we eat or drink anything that has sugar, this is what happens in our mouth. The pH level, let's analyze this graph. So this is number of minutes after we eat sugar, whatever it has, whatever food, drink with sugar. The second we put it in our mouth, the pH level is 6.5. So I'm just looking at the graph. Then immediately 6 minutes into we're swallowing the sugar. 6 minutes, look at the pH level. It drops to 4.8. I'm not sure. I'm just guessing. Okay. And then slowly, over the next almost an hour or more, it comes back to normal. Because apparently 6.5 is the normal pH level in the mouth. That's what I see from this graph. And it was determined with mathematicians and doctors and so on and so forth, a lot of testing, a lot of data, a lot of measurements. Okay, use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. So 42 minutes, I will say that is 6. So 42 minutes, approximately 6. Okay, part B. After eating sugar, when is the pH level the lowest? 6 minutes. Use the function's equation to determine the pH level to the nearest tenth. So now they want us to use this. By the way, what type of function is this? Careful. It's a ratio of two polynomials. It's a rational function, right? What type? Is it 2 or is it 1? It's 1. What is the horizontal asymptote? Of course, 6.5. Eventually, we'll get there at 6.5. After many minutes, the function, the pH level, will approach the normal value, which is 6.5. That's why this is a horizontal asymptote. Okay? So all they want us to do is now plug in 6 in the function. So to do that, we'll put the function in the graphing calculator. Don't forget parentheses around the top. 6.5 x squared plus, no, it's minus 20.4 x and plus 234. Close the parenthesis, and we divide by, close the parenthesis, please. Okay, divide by x squared plus 36. X squared plus 36. Okay. So I go to second in table, and I plug in 6. So 4.8. So coming back, it says determine the pH level after 6 minutes, 4.8. Part C, according to the graph, what is the normal pH level of the human mouth? What is the equation of the horizontal asymptote associated with this function? Y equals 6.5. The horizontal asymptote is where the function tends to go as x, or time in this case, approaches infinity. Use the graph, describe what it means. What does 6.5 or the horizontal asymptote mean? What does it mean? That eventually, if we stop eating sugar, because if we continue, I don't know what happens, but if we just swallow one piece of candy and then we stop eating sugar, then eventually about almost an hour later, the pH level in the mouth gets closer and closer to the normal pH level. Okay, so and we described what happens based on the graph. Any questions? Okay, let's look at one more. A drug is injected into a patient, and the concentration of the drug in the bloodstream is monitored, and C of T is in milligrams per liter. After T hours is modeled by this. Whatever function is this? Rational. Type? Exactly. The top has degree, and the bottom has 2. So what would be the horizontal asymptote for type 2? Always 0. So in other words, it does whatever, and eventually, as time passes, the behavior or the function gets closer and closer to perfect. Okay, so use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. So it says 0 to 10 with a scale of 1, and 0 to 3 with a scale of 1. So after 3 hours, 1, 2, 3, I'm going to say roughly 2.5. Use the functions equation displayed in the voice balloon by the graph to determine the drug's concentration after 3 hours. All I have to do is plug it in. So 5 times 3 is 15, and divided by 10. 9 plus 1. So that's exactly what we got, 1.5. I use the functions equation to find the horizontal asymptote. There is no need, because I only immediately looked at, once I looked at the function, I realized it's type 2, so the horizontal asymptote must be 0. And we hope for that, right? So when we get a medication, whatever it is, if it's an antibiotic or we are sick for whatever, and we get a medication, and we hope that that will dissipate in time. So unless there is something that some people have to be on for forever, for as long as they live, bless you, that's a different story. But other than that, we hope that we take a medication, it peaks to a high concentration, and then eventually will get out of our system. That's what we hope. So that's what the function is telling us. So you see, these are more sophisticated applications than the applications for quadratics. So what was the application for quadratics? One of them was the trajectory. I throw a ball up in the air, right? And it hits the ground after a certain time, and it peaks after a certain time, and then it hits the ground. And that's it. It's a quadratic trajectory. But these are more sophisticated functions. One of them deals with concentration of a medication in the bloodstream. The other one, for example, was the pH level in the mouth after swallowing sugar. Way more sophisticated applications than simply throwing a ball up in the air. Okay, that's basically all I had to say, unless we need to practice some more about 3.5, about rational functions. 3 types. The third one, it's a long story. I strongly recommend solve that problem on the test, and you will get extra credit for it. But I will not make the third one mandatory. No. I want you to see at least one so you know what it is. It's not a big deal, but it's a long process. So I would say too long for a test situation. So the last